Do you guys have any ideas what is the black hole? A black hole is a region in space where the pulling force of gravity is so strong that light is not able to escape. The strong gravity occurs because matter has been pressed into a tiny space. This compression can take place at the end of a star's life. Some black holes are a result of dying stars. Because no light can escape, black holes are invisible. However, space telescopes with special instruments can help find black holes. They can observe the behavior of material and stars that are very close to black holes. Primordial black holes are thought to have formed in the early universe, soon after the Big Bang. Stellar black holes form when the center of a very massive star collapses in upon itself. This collapse also causes a supernova, or an exploding star, that blasts part of the star into space. Scientists think supermassive black holes formed at the same time as the galaxy they are in. The size of the supermassive black hole is related to the size and mass of the galaxy it is in. Now we are going to know how is NASA studying black holes? NASA is learning about black holes using spacecraft like the Chandra X-ray Observatory, the SWIFT satellite and the Fermi Gamma Ray Space Telescope. Fermi launched in 2008 and is observing gamma rays, the most energetic form of light, in search of supermassive black holes and other astronomical phenomena. Spacecraft like these help scientists answer questions about the origin, evolution and destiny of the universe. Have you ever wondered how big are the black holes? Black holes can come in a range of sizes, but there are three main types of black holes. The black hole's mass and size determine what kind it is. The smallest ones are known as primordial black holes. Scientists believe this type of black hole is as small as a single atom but with the mass of a large mountain. The most common type of medium-sized black holes is called stellar. The mass of a stellar black hole can be up to 20 times greater than the mass of the Sun and can fit inside a ball with a diameter of about 10 miles. Dozens of stellar mass black holes may exist within the Milky Way galaxy. The largest black holes are called supermassive. These black holes have masses greater than 1 million suns combined and would fit inside a ball with a diameter about the size of the solar system. Scientific evidence suggests that every large galaxy contains a supermassive black hole at its center. The supermassive black hole at the center of the Milky Way galaxy is called Sagittarius A. It has a mass equal to about 4 million suns and would fit inside a ball with a diameter about the size of the Sun. A black hole cannot be seen because of the strong gravity that is pulling all of the light into the black hole's center. However, scientists can see the effects of its strong gravity on the stars and gases around it. If a star is orbiting a certain point in space, scientists can study the star's motion to find out if it is orbiting a black hole. When a black hole and a star are orbiting close together, high-energy light is produced. Scientific instruments can see this high-energy light. A black hole's gravity can sometimes be strong enough to pull off the outer gases of the star and grow a disk around itself called the accretion disk. As gas from the accretion disk spirals into the black hole, the gas heats to very high temperatures and releases X-ray light in all directions. NASA telescopes measure the X-ray light. Astronomers use this information to learn more about the properties of a black hole. So, the big question: what would happen if you fell into a black hole? If you leapt heroically into a stellar mass black hole, your body would be subjected to a process called spaghettification. No, really, it is. The black hole's gravity force would compress you from top to toe, while stretching you at the same time, thus, spaghetti. A supermassive black hole has a slightly less horrendous effect. So let's imagine then that you opt for one of these to make your giant leap for mankind and scientific research. Sagittarius A, pronounced Sagittarius A star, and abbreviated as SGRA, is a supermassive black hole at the heart of the Milky Way, believed to be around 44 million km across and containing approximately 4.31 million solar masses. It was discovered in 1974 by two astronomers, Bruce Spalek and Robert L. Brown, but remained unnamed until 1982. Your journey into Sagittarius A itself would begin after you slip over the event horizon, the point of no return. You would be able to see out from inside, but no one would be able to see you because any light would fall back on you. The good news is that although the gravitational pull is much stronger than smaller black holes, the stretching tidal force is less, meaning you won't be turned into spaghetti. But the bad news is you wouldn't be able to get out, or could you? Well, your hope lies in the theory of white holes. Put simply, if a black hole sucks things in, then a white hole spits them out again wherever that may be, and the two are connected via an interdimensional tunnel, known as a wormhole. Or, it's also hypothesized, if you waited long enough, the black hole will turn into a white one, anyway. This process is thought to take billions of years, but there's no reason to be disheartened. Why? Well, due to the intense gravitational forces within, time would be speeded up for you, so it would be over in a matter of milliseconds. Of course, at present, this is only a theory. If you want more proof of the inadvisability of swan diving into a black hole, consider the tidal disruption picked up by 3 NASA telescopes in 2014. It was caused by a star that had come too close to a black hole at the center of a galaxy, about 290 million light-years away. It was distorted, stretched, and shredded as it was sucked into the singularity, while the residue of a destroyed star was flung out in a cosmic belch. A black hole seems so dangerous to us. We often wonder, could a black hole destroy Earth? Black holes do not go around in space eating stars, moons and planets. Earth will not fall into a black hole because no black hole is close enough to the solar system for Earth to do that. Even if a black hole the same mass as the Sun were to take the place of the Sun, Earth still would not fall in. The black hole would have the same gravity as the Sun. Earth and the other planets would orbit the black hole as they orbit the Sun now. The Sun will never turn into a black hole. The Sun is not a big enough star to make a black hole. General relativity is a theory of gravitation developed by Albert Einstein between 1907 and 1915. The theory of general relativity says that the observed gravitational effect between masses results from their warping of space-time. Experiments and observations show that Einstein's description of gravitation accounts for several effects that are unexplained by Newton's law, such as minute anomalies in the orbits of Mercury and other planets. General relativity also predicts novel effects of gravity, such as gravitational waves, gravitational lensing, and an effect of gravity on time known as gravitational time dilation. Many of these predictions have been confirmed by experiment or observation, most recently gravitational waves. General relativity has developed into an essential tool in modern astrophysics. It provides the foundation for the current understanding of black holes, regions of space where the gravitational effect is strong enough that even light cannot escape. Their strong gravity is thought to be responsible for the intense radiation emitted by certain types of astronomical objects such as active galactic nuclei or microquasars. General relativity is also part of the framework of the standard Big Bang model of cosmology. As for conclusion, considering our galaxy alone holds 100 million stellar mass black holes, and that our own galaxy, the Milky Way, has a supermassive black hole at its center so enormous that it would fit inside the orbit of Mercury. Maybe it's time we started to learn more about these enigmatic phenomena. At least, just in case we ever find ourselves about to fall into one.